Hello everyone, welcome to Biswadeb classes. তো এই কিছুদিন আমার কিছু পার্সোনাল কাজের জন্য আমি না এই কিছু ভিডিওস তোমাদের জন্য আপলোড করতে পারিনি। তো তার জন্য আমি সবার কাছে প্রথমে সরি বলে নিচ্ছি যে সত্যি আমার এই কিছুদিন আমি সত্যি কিছু পার্সোনাল ইস্যু ছিল, যে কারণে পার্সোনাল কিছু প্রবলেম ছিল, যে জন্য আমি না এই ভিডিও বানাতে পারিনি। তো আজ থেকে আমি আবার রেগুলার বেসিসে ভিডিও বানানো স্টার্ট করছি। তো দেখো আমাদের যে চলছিল PYQ ম্যাথ মাইনারের জন্য, ওকে, PYQ ম্যাথ মাইনারে না আমি তোমাদের দেখবে প্রত্যেক কটা কোশ্চেন ইজি ল্যাঙ্গুয়েজে তোমাদের সাথে আমি এক্সপ্লেন করেছি। তো আজকেও আমি আমাদের PYQ এর আরেকটা যে পার্ট, সেই পার্টটাকে আমি তোমাদের কাছে ইজি ল্যাঙ্গুয়েজে ইচ অ্যান্ড এভরি কোশ্চেন ডিটেলসে আমি এক্সপ্লেন করব। ওকে, তো আজকের যে পার্টটা আমরা এক্সপ্লেন করব সেই পার্টটা হচ্ছে গ্রুপ বি কোশ্চেন নাম্বার 4 F and G। তোমাদের মনে আছে সাবজেক্টিভ পার্ট, এই দুটো ছিল আমাদের সাবজেক্টিভ পার্ট না? দেখো বেসিক্যালি দিস টু ওয়াজ মাই সাবজেক্টিভ পার্ট। এই দুটোই সাবজেক্টিভ পার্টের কোশ্চেন আমাদের করা মানে কমপ্লিট করা হয়নি। দুটোই দেখো 5 মার্কসের কোশ্চেন ছিল। আর তার সাথে সাথে গ্রুপ সি তেও আজকে আমরা সলভ করে ফেলবো। গ্রুপ সি অল অবজেক্টিভ কোশ্চেন। গ্রুপ সি হচ্ছে 5 A to D, these are all objective question। করলে আমাদের পেপারটা অলমোস্ট সবটা কমপ্লিট হয়ে যাবে, অলমোস্ট। দেন অনলি সাবজেক্টিভ পার্টটা আমাদের কাছে বাকি থাকবে কোশ্চেন নাম্বার 5 এর। ওকে, তো টাইম ওয়েস্ট না করে আমরা সরাসরি চলে যাচ্ছি আমাদের PYQ সলিউশন সিরিজে। ওকে, তো PYQ সলিউশন সিরিজের আন্ডারে আমাদের ফার্স্ট যে কোশ্চেনটা, কোশ্চেন নাম্বার 4 এর, দিস কোশ্চেন ইজ ভেরি ভেরি গুড কোশ্চেন and quite tricky। তো সুন্দর কোশ্চেন ছিল এটা। কোশ্চেনটা দিয়েছিল দেখো, বলছি যে ক্যাপিটাল A is a set, this set contains only 3 elements। The elements are 2 3 4। You have to find out the number of reflexive and symmetric relation defined on A। So before watching the solution of this question, just go through my solution, my video on relation। Okay, relation, this is a very important video. If you watch that video, you shall get a concept on reflexive and symmetric relation. What is called reflexive, what is symmetric? Okay, so this is a question, it's a very good question. You have to find out number of reflexive and symmetric relation defined on the set capital A। Now, that is a result. That's a very important result. The result is the total number of symmetric and reflexive relation on a set containing n elements. Suppose a set has n elements like this. Suppose there is a set like this, 1 2 3 up to n. There are n elements. Then the number of reflexive and symmetric relation that are possible on this set is 2 to the power n square minus n by 2. Okay, but how? What is the reason behind this? I'm explaining it. Okay, so see that I shall prove this result at first. Here we have n equal to 3. You can see that here my n is 3. So the thing is, initially suppose we have n elements. Suppose our set has n elements. Now how we can define a symmetric and reflexive relation defined on it? For this I shall form a matrix. I shall form a matrix. Suppose we are considering a matrix like this. See that. Suppose for reflexive relations, it means what? Reflexive means all the elements like this, A, comma A. This is called reflexive relation. So for reflexive relation, my matrix will look like this: 1 1 2 2 n n. See that these are called reflexive relation. A comma A. This pair must be in the set. থাকতেই হবে কিন্তু, okay? So this diagonal gives you reflexive relation. And for symmetric, my matrix will be, we know symmetric means what? If A comma B belongs to R, this implies B comma A belongs to R. I again telling you, go through my video on relation. Okay, after that you can understand the concept of symmetric relation and reflexive relation. So for symmetric relation, my set, my matrix must look like this. If 1, 2 is there, 2, 1 must be there. If 1, 3 is there, then 3, 1 must be there. So like this, if 1, n is there, n, 1 must be there. So this will be my matrix. Okay, the structure of the matrix will be this. If 1, n is there, n, 1 must be there. So this entire matrix gives you a symmetric and a reflexive relation. Okay. This diagonal gives you number of reflexive relation, and its off diagonal gives you number of symmetric relation. So this entire matrix gives you fulfill my entire condition of symmetric and reflexive relation. So first of all, see that this diagonal position must be fixed only in one way. Diagonal guloke na only one way to fix kora jay. Ki hobe? 1, 1, 2, 2, n. Okay, there is no other way. You can't put at this position any other element. You can't put at this position any other element. 1, 1 must be there, 2, 2 must be there, n must be there. So the diagonal can be filled up by only one way. I'm writing here. My reflexive relation means my all diagonal elements. Here the diagonal, okay, diagonal elements can be filled up in one way. 1, 1, 2, 2, and n. There is no other possibility. Okay. So my diagonal elements in one way, that means my number of reflexive relation is 1. Okay, only one reflexive relation can exist. Like 1, 1, 2, 2, and n. So only one reflexive relation. Now coming to the main part, how many symmetric relation are there? Now it's a very, very important part. How many symmetric relation are there? See that there is an n cross n matrix. There is an n cross n matrix. And we know in an n cross n matrix, number of elements for an n cross n matrix, its number of elements is n squared. Why n squared? See that suppose there is a matrix 3 cross 3. How many elements it can have? It can have 9 elements, 3 squared element. Okay, 3 squared. So, like actually, if a matrix is a 3 cross 3 order, it has 9 elements: 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. That means there are 9 elements. And how we can get these 9 elements? This can be 3 squared. So for a 3 cross 2 matrix, the number of elements is 3 squared. For a 2 cross 2, it is 2 squared. Okay, and so on. So the number of elements in this entire matrix will be n squared, right? You can easily verify this. Then see that there are n diagonal elements. There are n diagonal elements. So if you exclude all the diagonal elements, then excluding diagonals, my number of elements will be n square minus n. Why? Because there are n diagonal elements, 1, 2, 3, up to n. See that there are n diagonal elements. So excluding n diagonal elements, we have total number of elements equal to n square minus n. And obviously, these elements are my off diagonal elements. This n square minus n of diagonal elements that left. Okay. So these are my off diagonal elements. So I can repeat, total number of elements for an n cross n matrix is n square. And if we exclude all the reflexive relation, means all my diagonal elements, my number of off diagonal elements, that will be n square minus n. Now see that these off diagonal elements will form symmetric relation, right? these off-diagonal elements will form symmetric relation. Okay. Now there are n square minus n of off-diagonal elements, but see that for a symmetric relation, if 1, 2 and 2, 1 will be same pair. Okay, will be same pair. Why? Because if 1, 2 is there, 2, 1 must be there. You can't form a symmetric relation where only 1, 2 is present, but 2, 1 is not present. You can't form. To form symmetric relation, now you have to include both 1, 2 and 2, 1. That means we can consider 1, 2 and 2, 1 as the same pair because they must be there. Similarly, if 1, 3 is there, then 3, 1 is there. What is the meaning of that? That means this n square minus n elements, n square minus n elements can be divided into two parts, into two equal parts. Because if A comma B is in relation, then B comma A must be in relation. That means you can't count A comma B, B comma A in separately. A comma B or B comma A ke separately count kora jabe na. Okay. So what? Then what we can do? Basically, so see that though we have n square minus n element, but we are dividing this into two groups. So we must have n square minus n by 2 of diagonal elements. See that by off diagonal elements are n square minus n, that is okay. But since 1, 2 and 2, 1 are we are considering 1, 2 and 2, 1 as the same pair. Because if 1, 2 is there, 2, 1 must be there. They can't be count separately. ওটাকে separate count করা যাবে না। তাই তাহলে দেখো তাহলে আমার তাহলে off diagonal element reduce করে গেল। কতগুলো reduce করে গেল? n square minus n by 2. Because only 1 to count করলেই হবে। 2, 1 automatically include হয়ে যাবে। Okay? If we count only 1, 2, 2, 1 will be automatically counted. You don't need to count separately 2, 1. Similarly, if we count 1, 3, 3, 1 will be automatically there. That means though we have n square minus n of diagonal elements, but we are dividing them, we are counting them as n square minus n by 2 of diagonal elements. Because of this reason, since if 1, 2 is there, 2, 1 must be there. Okay. So if so my total number of off diagonal elements, that will be n square minus n by 2. So like A comma B and B comma A. Okay, this is called grouping. We are grouping them. Say A comma B and B comma A in the same group. Like this, say 1 comma 2 and 2 comma 1 will be in the same group. You can't count them as two different pairs. ওদেরকে কিন্তু দুটো ডিফারেন্ট করে কাউন্ট করা যাবে না। তুমি যদি ওদেরকে দুটো ডিফারেন্ট করে কাউন্ট করো ডিফারেন্ট, দেন n স্কয়ার মাইনাস n অফ ডায়াগোনাল এলিমেন্টস থাকবে। বাট তুমি এদেরকে ডিফারেন্ট করে কাউন্ট করতে পারবে না। You can't count them separately because they must belong to same group. তুমি এরকম করতে পারবে না যে you are taking only one. You have to take both of them. Okay. Similarly, 1, 3, 3, 1 must be in the same group. Okay. That means this entire n square minus n divided into two different two groups, and that is why we have total number of n square minus n by 2 of diagonal elements. Okay, just I'm giving you the example. Suppose my set contains, I again give you an example. Suppose my set contains 2, 3, 4. Suppose not, it is given in question. My set contains 2, 3, 4. So my relation will be 2, 2. My diagonal will be this. This is my symmetric. This is my reflexive relation. My symmetric relation will be 2, 3, 3, 2. 2, 3, 3, 2. Then say 2, 4, 4, 2. Then 3, 4, 4, 3. So see that if we count 2, 3, you don't need to count 3, 2. If we count 2, 4, you don't need to count 4, 4, 2. If you count 3, 4, you don't need to count 4, 3. So though, see that, though there are 6 of diagonal elements, can you observe this? There are 6 of diagonal elements, 1, 2, 3, 4, 5, 6. But I am counting only 3. I am counting only 3. That means though there are 6 of diagonal, but I am taking only 6 by 2 is equal to 3. To form a symmetric relation. Symmetric relation form korte gele only 3 take count korlei cholbe. This and this. Era 3 jon automatic include hoye jabe. This 3 will be automatically included. Okay. This is a clear visual for you. Okay. So we have n square minus n by 2 of diagonal element. Okay, done. I think all of you understand this concept. Why there is n square minus n by 2. So for symmetric relation of diagonal element must be n square minus n by 2. Okay. Now see that this 2, 3 and 3, 2, this pair may belong to this set or no. Why? I'm giving you the example. We have to form symmetric and reflexive relation, right? So my one symmetric and reflexive relation can be this. 2, 2. See that for reflexive, we know 2, 2, 3, 3, 4, 4 must be there. Must 2, 2, 3, 3, 3, 4, 4. Era always থাকবে. And then আর কেউ না থাকলেও হবে. There is still a symmetric and a reflexive relation because all the criteria of reflexive and symmetric are satisfied. Then another set can be, suppose it is A1. Another set can be 2, 2, 3, 3, 4, 4. Then 2, 3, 3, 2. 2, 3, 3, 2. There is another reflexive and symmetric relation. You don't need to take all of them. Okay, so this is a reflexive and symmetric relation. There is also a reflexive and symmetric relation. Similarly, you can include 2, 3, 3, 2, 2, 4, 4, 2. Okay, like this. So what I'm telling you is, see that in this set, 2, 3 is not there, but in this set, 2, 3 is there. Okay, that means there are 2 possibilities for 2, 3. There are 2 possibilities for the pair 2, 3. Either it is included in this set, yes, it is included, or it is not included in this set. Still, it is both symmetric and reflexive relation. Both the criteria are satisfied. Either this pair 2, 3 is included in the set. Just go to this example. Either this pair 2, 3 is included in the set or not included in the set. So there are 2 possibilities for this pair. Okay, there are 2 possibilities for this pair. Like this, there are 2 possibilities. There are 2 possibilities for each pair. প্রত্যেক কটা পেয়ারের জন্য না দুটো করে পসিবিলিটি থাকবে। কি কি পসিবিলিটি? Either included, yes, or not included. Just go through these 2 examples. Okay, that means for each pair there are 2 possibilities, and we have how many pairs? We have n square minus n by 2 pairs. So total possibilities is equal to 2 to the power n square minus n by 2. This is a basic concept of permutation and combination. For example, suppose we are tossing a coin n times. We know this basic concept of permutation combination. Suppose we are tossing a coin n times. Each time either head occur or tail occur. So how many possibilities are there? 2 to the power n possibility is a very basic basic idea of permutation combination, and this concept belongs to my HS course, class 11 course. For each pair, we have two possibilities. Either this pair is included or this pair is not included. So for each pair, there are two possibilities. And we have n square minus n by 2 pairs as a whole. So my total possibilities will be 2 to the power n square minus n by 2. Okay. So this is the proof of this result. So number of reflexive relation is 1, number of symmetric relation is 2 to the power n square minus n by 2. So total number of reflexive and symmetric relation is equal to 1 into 2 to the power n square minus n by 2. So just prove this theorem in exam. Okay. So this is my proof of this result. Now coming to solution of this question, how many elements are there? There are 3 elements. So here my n is 3. Sorry, my n is 3. So my total number of reflexive and symmetric relation, that must be 1 into 2 to the power 3 square minus 3 by 2. 3 square minus 3 by 2, giving you 9, 6, I think 2 cube is equal to 8. There are 8, total number of 8 symmetric and reflexive relation. What is it? Just go through this calculation. Okay, it's a very, very good question. If you have any doubts on this question, you can definitely ask me in my comment box. Okay, definitely. I shall clear your doubt in my next video. Okay. So just go through this question. My next question, question number G, is a question on mapping, and I have done so many questions like this in my video mapping. There are 4 parts of that video. Okay, don't miss those 4 parts. Go through these 4 parts. Okay, you can clear all your doubts from mapping. Another thing that I want to inform, I'm going to start my batch from September. From September, first week. This is for third semester. Third semester mathematics. So if you are interested, you can contact me. Okay. Contact number is given in my description box. So because as we know, our main semester exam for semester 2 will commence from November, and I think it's very late. So if you have to start your third semester course from September onward. Okay. Otherwise, you can't cover the entire syllabus because syllabus is very huge. So jara interested math korte tara contact kore niyo je description box e dewa ache আমার contact number আর সেপ্টেম্বর থেকে আমার ম্যাথমেটিক্স এর ব্যাচ স্টার্ট হচ্ছে ওকে ফ্রেন্ডদেরকেও জানিয়ে দিও যারা ইন্টারেস্টেড তারা করতে পারে জয়েন সো এই কোশ্চেনটাতে তাহলে আসা যাক this is a question on mapping. Again repeat, go through my video on mapping. We are given a function fx equal to this x minus 3 by 2x plus 1. You have to check whether f inverse exists or not. We know the condition of f inverse, existence of f inverse. It should be 1 to 1. It should be on 2. It should be 1 to 1. It should be on 2. So at first we shall check 1 to 1. How to check 1 to 1? Let x1, x2 belongs to, we know this is called domain. Okay, one more thing. R slash minus R, it means what? It means all real number except minus R. You can take all real number, but don't take minus R. This is called our domain. We know this is called domain. And similarly this is called our codomain. This is our codomain. All real number except half. So let x1, x2 belongs to R minus R. We can also write like this. So we know that x1, x2 must belongs to the domain. My domain is this. Now fx1 is equal to fx2. How to check 1 to 1? Let fx1 equal to fx2. Now, what is fx1? Put x equal to x1. What is fx2? Put x equal to x2. Okay. Next, cross multiply. 2x1 x2 plus x1. See that 2x1 x2 plus x1 minus 3 to the 6 x2 minus 3 is equal to 2x1 x2 2x1 x2 minus 6x1. Okay, see that just multiplying them. Or okay, 2x1 x2 minus 6x1, then x2 minus 3. Now this gets cancelled. Okay, and see that if we take minus 3 gets cancelled, then take all of them together. So x1 minus 6x2 plus 6x1 minus x2 is equal to 0. Then x1 plus 6x1, okay, that is 7x1, and minus 6x2 minus x2 minus 7x2 equal to 0. Take 7 common, and then you can write x1 minus x2 equal to 0. It's a very basic calculation. So assuming fx1 equal to fx2, we obtain from this, we can write x1 equal to x2. And we know, assuming fx1 equal to fx2, we obtain x1 equal to x2. And we know there is the condition of 1-to-1 mapping. So yes, this mapping is 1-to-1. Okay, this function of this mapping is 1-to-1. Assuming fx1 equal to fx2, we obtain x1 equal to x2, and that is called 1-to-1 mapping. So 1-to-1 mapping part is done. Yes, it is 1-to-1. For onto, recall. What is the meaning of onto? For onto, we know at first express x in terms of y. X ke express korte hobe y er terme, tai na? Recall. I again repeat, go through my video on mapping. We are given y is equal to x minus 3 by 2x plus 1. So from this, we have to express x in terms of y. Take cross multiplication. And take all x term together. X গুলোকে এক জায়গায় নিয়ে আসো না আর y গুলোকে আলাদা করে দাও. Take all x together and y. Okay, then in other question. So 2xy plus y is equal to x minus 3, and they will keep giving you this. Okay. Then what? Then we can say that we can take x common, then 2y minus 1, and taking minus common 3 plus y. So basic calculation. Then my x will be minus of y plus 3 by 2y minus 1. And to avoid this minus sign, we can write this as 1 minus 2y. It's a very basic calculation. No? Just cancel minus minus from numerator and denominator. This become 1 minus 2y. Okay. Now what? This is my domain. This is my codomain. Now what we need to do? We have to check for all y whether there exists x or not. Right na? It is the whether for all y there exists x. But see that if 1 minus 2y is equal to 0, that means y is equal to half. If y is equal to half, my x equal to infinity, because if my denominator is 0, my x will be something by 0, that will be infinity. So if y is equal to half, if we take y, we know that there is a position of y. If we take y equal to half, there does not exist any x. কোনো x exists করবে না, cross করে দিচ্ছি, cross. If y equal to half, there does not exist any x. Writing it here. This implies if y is equal to half, there does not, sorry, there does not exist x. Because আমি যদি y জায়গায় half put করি না, if we put y equal to half, my x equal to infinity. That means it is not onto, because y equal to half does not have any pre-image. Half এর কোনো pre-image আছে? নেই. That means it is not onto. But this is wrong. This is wrong. Because see that in my codomain, half is not included. See that my codomain does not include half. তার মানে কি y equal to half included in a. My codomain is except half, all other things, all other numbers, except half যে কোনো number. তো half আমার তো codomain এ belong করছে না। দেখো না, again repeat, if y equal to half, my x become infinity. But the thing is, y equal to half does not belong to this codomain. তার মানে কি? That means, তাহলে আমার কি হবে? দেখো, but half does not belong to codomain. Half codomain এ belong করছে না। তার মানেটা কি? তার মানে yes, for all y belongs to here, my codomain, there exists x. There exists x such that fx equal to y. Just go through my video on mapping. That means yes, it is my onto mapping. I get it, দেখো, only for y equal to half কোনো x exist করে না। But y equal to half তো codomain এ belong করছে না, নেই codomain এ half। দেখো, only for y equal to half কোনো x exist করবে না, but y equal to half belong করছে না codomain এ। That means for all y there exists x that belongs to this, such that my fx equal to y, and hence my mapping is onto. So this mapping is both one-to-one and onto. Okay. So my conclusion is my mapping is both one-to-one and onto. This implies f inverse exists. So my answer is yes, f inverse exists. There is a proof. Okay. And see that my 2x plus 1 cannot be 0. Because if 2x plus 1 equal to 0, my fx will be undefined. And দেখো, 2x plus 1 equal to 0 মানে x equal to minus half. That means x cannot be minus half. That is why they have excluded minus half from domain. ওরা এই রিজনের জন্য না minus halfটাকে exclude করেছে domain থেকে. There is a reason. This question is done. If you understand this video, please like and share, and don't forget to comment. Okay, কোনো কমেন্ট করতে ভুলো না, আর লাইক আর শেয়ার করে দেবে। See that, so there is everything from this group. My group B is also done, my group A is done, only group C is left. Now we shall solve all the objective questions in this video, and my next video I shall discuss all subjective questions. That's over, my paper is over. So this is my first question. This first question is verify whether the set of vectors this is linearly independent. It's a very easy question. Okay, what is the meaning of RQ? This is an important concept behind RQ, but in this video I am not going to explain you. I'm just giving you the meaning of RQ. RQ means in easy language there are 3 components. There must be 3 components. That's it. Like this. This is a vector space like this, x, y, z. এগুলো আমরা ডিটেইলসে আমাদের ক্লাসে আমরা করেছি। তো যারা ক্লাস করেছে তারা ডিটেইলসে জানো, বা যারা করোনি তারা আমি তাদের জন্য ডেফিনেটলি ভিডিও বানাবো। ওকে, ডেফিনেটলি তার জন্য ভিডিও বানাবো ভেক্টরের উপরে। যারা ক্লাস করেনি আমার কাছে, আমি তাদের জন্য আমি কিছু ইউটিউব ভিডিওস বানাবো। ওকে, ভেক্টরস এর উপরে। তো এনিওয়ে, সো RQ মানে তোমাদের কাছে খুব ইজি ল্যাঙ্গুয়েজে there must be 3 components. These are called components. This is my first component, second component, this is third component. If it is given r square মানে কিরকম হবে x, y. Okay, these are called vector spaces. Okay, whatever. So we have to verify whether the set of vectors are linearly independent or not. What is the there is a theorem. There is a theorem. Suppose my alpha vector is 1, 5, 2. My beta vector is 1, 1, 0. My gamma vector is 0, 0, 1. Very soon I shall prepare a video on vector space. And we have to check whether they are linearly independent or not. There's an easy theorem. Form a determinant with these vectors. Okay, there's a result. Form a determinant with these vectors. 1, 5, 2, 1, 1, 0, 0, 0, 1. Form a determinant with the help of these vectors. Now check whether this determinant is 0 or not. If this determinant is not equal to 0, implies they are independent. And if this determinant is equal to 0, implies they are dependent. This is the theory. Just from a 1, 5, 2, 1, 1, 0, 0, 0, 1. Check whether this determinant is 0 or not. So we shall find out this value of this determinant. Expand with respect to this 1 into its cofactor. Okay, plus, minus, plus, minus, plus. We know. Then 1, 5. This cofactor is this. Its cofactor is this. 1, 5, 1, 1. After calculation, 1 into 1 is 1. 1 minus 5, it is minus 4. Clearly it is non-zero. Clearly it is non-zero, and since this determinant is non-zero, it is independent. So yes, they are independent. It's a very easy question. Very, very easy question. My previous question on mapping was also very easy. If you go through my video on mapping now, you can easily answer this question. Okay, and again, it's a very easy question on vector space. So this question is done. My next question. You are given a subset 2x plus y minus z is equal to 0. You have to form a spanning set. We know what is spanning set. Spanning set means a set that generate this subspace. We have to find a spanning set. So see that there are so many methods of solving this question. Okay, there are so many methods. You have to find a spanning set. So for this, you can write this as z is equal to 2x plus y. Okay, see that we can write z is equal to 2x plus y. You can write x as well. You can write y as well. Then my set will be my x remain as it is, my y remain as it is, my z become 2x plus y, where my x, y are real numbers. Obviously, my x, y should be real. Belongs to R. R means real numbers. Okay. So this is the structure of the set that will span this subset. This is my structure of the set that will span this subset. Okay. For example, see that how we can write this. We write z in terms of x and y. You can also write y in terms of x and z. In that case, you shall get another spanning set. You can write x in terms of y and z. This will be my another spanning set. So there can be so many spanning sets. For example, suppose there is a particular spanning set. See that this set can be written like this. Separate x and y. See that there's a trick. Separate x and y. We have done this trick in our classes. Okay. এগুলো আমরা করে থাকি আমাদের ক্লাসে, খুব ইজি বেসিক কোশ্চেন। দেখো কি করে করছি, দেখো আমি x আর y টাকে না সেপারেট করে দিচ্ছি। We are separating x and y. See that this is my first component. In my first component, coefficient of x is 1, and in my first component there is no y. তার মানে কি coefficient of y will be 0. এটা দেখো x এর coefficient কত? My coefficient of x is 1. and my coefficient of y is 0. Now look at the second component. What is my second component? My second component is y. So here my coefficient of x is 0 because y can be written as 0 into x plus 1 into y. So here my coefficient of x is 0, my coefficient of y is 1. My first component was x. X can be written like this. So coefficient of x is 1, coefficient of y is 0. My third component is 2x plus y. Here my coefficient of x is 2, my coefficient of y is 1. See that in that case we can say that 1, 0, 2, 0, 1, 1. Is a vector. These two vectors span S. A duto vector is the span করবে. That's all. So this is my spanning set. After writing this spanning set, do this portion. You don't need to show this in exam. So these two vectors span this entire set, yes. But I again repeat, these two vectors are not unique. There can be more vectors like this that will span S. Okay? But এটা only আমাদের solution video তো এই solution videoতে এত concept possible না বুঝতেই পারছো তাহলে ভিডিওটা এত লং হয়ে যাবে না যে তোমরাই আর ইন্টারেস্ট পাবে না okay it's not possible to explain all this concept in the single video otherwise it will be too long so this is a particular spanning vector the spanning vector will span this কি করে করলাম বুঝেছো কোএফিশিয়েন্ট গুলোকে সেপারেট করে দাও separate the coefficients x or y like this. In this first portion, my coefficient of x is 1, my coefficient of y is 0. In my second portion, my coefficient of x is 0, my coefficient of y is 1. And here, coefficient of x is 2, coefficient of y is 1. So, these are my spanning vector. It's 1, 0, 2 and 0, 1, 1. See that? That's the question again. See that we are given A is invertible. A is invertible means what? A inverse exists. A inverse exists. We are given the product of these two matrices is 0. 0 is a null matrix. 0 is a null matrix. Null matrix means ki? Null matrix means is all the components are 0. All the components are 0. It is called null matrix. So we are given A equal to 0 and A inverse exists. So we are multiplying both sides with A inverse. We are multiplying both sides by A inverse. Now we are using associative law of matrix inverse. Matrix. Okay, associative law of matrix is we know associative law says we can take these two matrices together and something into null matrix gives you null matrix. Something into null matrix gives you a null matrix. And this is my associative law. Associative law. This is the basic law on matrix. Now, A inverse into A is I, identity matrix. And do you know I means identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. And finally, we know identity matrix into something gives you that matrix. My proof is complete. Okay? Identity matrix into something gives you that matrix. This is how easy this question is. Okay? Such that this matrix has its own inverse. Own inverse means what? Given A is equal to A inverse. This matrix is inverse of itself. Okay, so there are so many methods of solving this question. Okay, অনেক মেথড এটা আমরা সলভ করতে পারি, বাট এক্সামে আমরা যেটা ইজিলি করতে পারি সেটা করাচ্ছি। ওকে, ইন এক্সাম দ্যাট হোয়াট উই ক্যান ডু ইজ উই আর গিভেন দিস ম্যাট্রিক্স ইজ ইটস ওন ইনভার্স, মানে এ ইজ ইকুয়াল টু ইনভার্স, ও নিজেই নিজের ইনভার্স। ওকে, এরপর দেখো এখানে এ দিয়ে মাল্টিপ্লাই করে অনেক মেথড আছে, বাট দেখো বেসিকলি আমরা ইজ আ 2x2 ম্যাট্রিক্স তো। সো দেখো it is my A, and we know for a 2x2 matrix how to find its inverse জানা আছে? আমি বলি, এরা দুজন না প্লেস চেঞ্জ করে, মানে ল্যামডা এখানে আসবে 1 এখানে আসবে, these two elements interchange their places. আর এই দুটো এলিমেন্ট কি করবে বলতো, সাইন চেঞ্জ করবে। মানে এটা প্লাস থাকলে মাইনাস হয়ে যাবে, মাইনাস থাকলে প্লাস, and divided by its determinant. The 2x2 matrix এর ইনভার্স বার করার ইজি মেথড। এই দেখো কিরকম হচ্ছে, দেখো ধরো এটা একটা ম্যাট্রিক্স আছে, তো এই 2x2, this property holds for 2x2 matrix only for 2x2 matrix। কি হয় দেখো, এরা দুজন প্লেস ইন্টারচেঞ্জ করে আর এর সাইনটা চেঞ্জ হয়ে যায়, এটা প্লাস আছে তো মাইনাস, প্লাস আছে তো মাইনাস। By taking, it's a shortcut method of finding inverse of 2x2 matrix. I again repeat, this rule holds only for 2x2 matrix. এরা দুজন প্লেস ইন্টারচেঞ্জ করবে, এরা সাইন ইন্টারচেঞ্জ করবে, দ্যাটস ইট। সেকেন্ড একটা প্লেস ইন্টারচেঞ্জ করছে, এটা 0 তো 0ই থাকছে, এটা 1 তো -1। By taking, this implies 1 0 1 lambda. Now what is determinant of it? Determinant of A is 1 into lambda minus 0 is equal to lambda. So determinant of A is lambda. Then if we say that 1 0 1 lambda remain as it is, and if we divide by lambda, this will be 1, 0 by lambda korle 0, this will be minus 1 by lambda, and this will be 1 by lambda. Okay, right? Say that lambda by lambda is 1, 0 by lambda is 0, it's a minus 1 by lambda and 1 by lambda. Now what? Now compare them component wise. Mane, there is my 2,2th element. Okay, equal to. There is my 2,2th element in this matrix. It is my lambda. And this is my 2,2th element in this matrix, 1 by lambda. Okay, say that. There is my 2,2th element in this matrix, and there is my 2,2th element in this matrix, and there is an equality sign. That means this equal to this. Well, কি হবে? Lambda square equal to 1, on a lambda equal to plus minus 1. So this is the answer of this question. You can also equate this with this. You can also equate this with this. And from this, you shall get lambda equal to -1. But lambda can be +1 as well. Okay? Say that. So these are these are my structure of the matrix. Okay, so the lambda can be either +1 or -1. So this is the solution of this question. Now there is an alternative method. The alternative method is, given A equal to A inverse, take determinant on both sides. Taking determinant on both sides. So date A is equal to date A inverse. Now date of A inverse money 1 by date A. 1 by date A. This implies date A whole square is equal to 1. This implies date A equal to plus minus. This is an interesting method. You can apply this method. Now, what is my date A? My date A is lambda equal to plus. What is my date A? Date A is 1 into lambda. So see that, same answer. So either use approach 1 or use approach 2. This is my method 2, and the previous one was method 1. So either you can go to method 1 or method 2, but method 2 is, I think, quite simple method. Na? But যদি মাথায় না আসে, then কি করবে? Go to my method 1. Method 1 তো মাথায় আসবে। Method 1 তো খুব easy. Otherwise, you can use this method as well. Okay, using this property, date A inverse equal to 1 by date A. So this is everything from this lecture video. And the next video, I shall solve all subjective questions from vector and matrix. Okay. So, আবার দেখা হবে সবার সাথে next video তে. Till then, bye bye.